So today, I thought we might take some time and grab a whiteboard and talk about the components of a conversation you might have with AI. And we're going to talk about some foundational concepts that I think can be really complicated, and it would be really easy for me to go 2 hours here. And so the goal is going to be to do something more like 20 minutes. What I want to try to do is stick to what I think are the core concepts that really help us think about how we build systems for AI and how we interact with those systems. There are some major components that I think get conflated, misunderstood, poorly explained. And a lot of this is no fault of anyone's. The reality is that most all of our knowledge is pretty lumpy here right now. AI is a very fast-moving thing. How we work with it, how we build systems around it, how we harness it to get work done is something that, is dramatically different today from how it was 6 months ago, when we still were barely even starting to be sure that that was going to ever be really possible, from a year ago when that was still absolutely a science project. So now, one thing we have to think about is 6 months from now, a lot of what I'm talking about now will have been true now, but might have deviated some from how people are still working with these systems. Nevertheless, I think these are some pretty foundational concepts that are solidifying and will benefit you a lot to extract the information hopefully I can impart today. There's a lot of components that make up an agentic system. And today I'm going to try to sort of latch on to an exemplary, fairly simple version of that and break them out into some logical concepts, walk you through them so that you kind of understand terms and verbiage that we use a lot in this space. AI, agents, harness, context, model, inference, provider. A lot of these things that are kind of foundational, but can get conflated and misunderstood. So let's jump to the whiteboard. There's no script here. I'm totally shooting from the hip, so the quality level is going to be what it is. But I'm hoping to share some things that I know with you, so that we can maybe both be a little less lumpy in our knowledge going forward. So I'm just going to start with some shapes, no plan. The first thing to talk about is the model. And this is really what I'm talking about here is not just the model. I'm talking about the provider, the provider of inference. I'm talking about sort of the systems that wrap all of that, right? So the upstream. So whenever I go use something like Claude or ChatGPT, I'm interacting with an inference provider. And an inference provider, OpenAI, Anthropic, xAI, all of the different Chinese providers, Alibaba, etc. What they're doing is a couple of things, right? So they likely have developed or are hosting an AI model which lives on their computers and takes up a lot of memory, and you can interact with it. And these models are, once you're kind of consuming the memory and you stand them up, to send some text in and have it do its fancy autocomplete and send you text back is a very inexpensive round trip operation. You could, at a fraction of the compute being used for AI today, you could respond to all of the AI requests in the world with no contention whatsoever miles ago. The part that makes AI expensive, the part that makes it to where we need all of these data centers and servers and these providers are, absolutely, Anthropic has shown us multiple times this year where they have been absolutely strapped for compute, trying to find a way to balance the usage from their consumer subscriber tier and their real money-making enterprise API tier customers by constantly changing the rules on us. And they're not doing this because they want to piss us off. They're doing this because they are strapped for compute, and they're strapped for compute because of inference. So when you send a prompt or a message or a request into an AI model, we know, I think a lot of us by now understand roughly how these things work. It is a box that produces language. You send some language in and it tries to sort of take that language and keep going and produce language out. And the earliest language models we saw, that's literally all they did. Like we've seen the examples with like Shakespeare, where you just feed it a lot of Shakespeare and it just starts writing fake Shakespeare. And that's how that works. But to get real useful outcomes from an AI model, you need inference. And inference is where we start to make these models a lot more complicated, and they have a lot of layers to them. And the steps that go through text coming in at the top and all of the different components that occur inside of that model, as it has concepts like attention and the KV cache and all of these different components that go into making sure you get output that's reasonable out the other end, goes way beyond just a quick kind of turnaround text generation. Most all the models today are what we call reasoning models. And these models sort of run their own upstream loop where text comes in, they consume this text, and they generate some text, but they don't send that text that they generate back to you. They read it themselves as like a follow-on looping prompt, and then they criticize it themselves, and they have this inner monologue until they finally arrive at a point that matches all of the training and the tuning and the requirements in order to get to a state where they're ready to deliver a response. And I've already gone kind of deeper here, and I've been vague a bit because I'm trying to avoid making a whole video about that, right? We're already 6 minutes in and I barely started. So I'm going to try to compress this a bit. The upstream provider provides the thinking, they provide the reasoning and all the compute and time that it takes to do that well. But in order to do this well and safely, they have to bolt on a lot of additional components here. So up here in this model provider upstream box, we're going to start hammering in some stuff that they're doing, like auth, rate limiting, input validation, and safety. So something like, can you help me develop a strain of anthrax? Is something that Claude's probably not going to be excited to help you work on, and that's because of input validation. So the model on the back end might be willing to work on some of these things, but these providers are doing validation usually with other AI models or the same model running in kind of a different harness, which we're going to get to in a second. Validating your inputs to make sure you're not up to malicious intent, etc. So there's a lot more components here too. There's oftentimes sort of like a pre-prompt or something along the lines of a system prompt up here, where there is a text going ahead of your prompt that's hitting the model that you can't see. Good example for this, I was trying to think of a few. There's been a few. So if you'll recall, I think it was last year, there was the whole debacle with Grok, where Grok just went like mega unhinged at one point and started saying a lot of really like heinous racial slur stuff on Twitter. When the post-mortem of this all went down, what actually occurred was this pre-prompt, or kind of like provider side system prompt, that XAI had provisioned to go ahead of whatever the user says, contained some verbiage which seemed harmless enough, but essentially unshackled the agent and made it respond in an unhinged, kind of absurd way. And that is an example of that. Another good example would be, I think it was GPT-5.5 from OpenAI, was really obsessed with talking about mythical creatures. Specifically, I think it was goblins. So in its output, it would constantly refer to mythical creatures and specifically goblins. So like you would ask it for something and it would call something a goblin, or like, and it was generally contextually correct. I have some examples from my own usage of this where it would respond back with like talking about like a possible foot gun in some code and like refer to it as a goblin. So it would say it in ways that made sense, but it just really wanted to use those tokens. So they could go in and put in pre-prompt that says like, never under any circumstances talk about goblins. Like, we're not here for the goblins, unless the user literally sent you a message asking about like the history of goblins, shut the hell up about the goblins. So that is what kind of the provider pre-prompt component is. And then there's a lot more going on up here. So there's just like all the upstream configurations and everything that they're doing kind of behind the curtain that is the provider. Now, one quick thing as I wrap this section up to mention is that, this doesn't have to be hosted, right? You could be self-hosting something like a Gemma 4 model, right? Or a GLM model or something that you have gone and pulled an open weight model and spun up enough compute and you're hosting it. And then you actually in that scenario control all of this. And you might choose to use some or none of these components. And in a scenario where you're self-hosting, this might literally all be very collapsed into just being upstream reasoning and inference and intelligence. Okay, so let's move on into the more interesting stuff. I wanted to break that down though, because one thing that I think a lot of people don't know is that whenever your prompt goes into Claude or goes into ChatGPT, a lot of additional flavor is getting sprinkled onto that prompt before it lands with the actual model to reason about it. Okay, next up, the meat and potatoes here is going to be the harness. So harness gets thrown around like crazy, right? I feel like we hear about harness engineering and people are always talking about the harness, and some people are like, what's this new thing, the harness? And somebody will say, well, the harness, that's the tools that the agent uses, or the harness, yeah, that's the guardrails. The harness is the guardrails that keeps the agent on track with the work you want to get done. Well, the harness is actually, the agentic loop, the way the agent's able to get things done and not just respond to a question. All of that's true, but I think it's worth fleshing it out a little bit. So we're gonna grab us a little harness. We're gonna grab us a new shape here. Let's go with the box again. We like the box. Let's make a big one. Let's hammer out some of the stuff that goes into the harness and just talk about it a little bit. So what are the big components? Well, first, conceptually, the harness is the normal software running on a normal computer that allows an upstream provided AI model, everything up here, to interact with some local compute context work, whatever. It's kind of like the terminal between the AI and the work. And it is sometimes a very simple piece of software, but usually it's a pretty complex piece of software that has a lot of moving parts. And we're not going to cover all of those, but I want to hit the big ones. So one of the biggest things, and I think as we focus a little bit on what really goes into the model whenever you send a prompt, let's take that path and talk about, let's start with the orchestrator logic. So whenever you send a message into a harness, this kicks off the orchestrator logic, which then begins to step through all of the different deterministic paths of code that exist there. And one of the first things that typically comes through is a system prompt. And we're going to refer to that as its more maybe proper name, which is privileged. Is that a brain explosion? I think that's right. Privileged instructions. So privileged instructions are basically going to be a prompt that is built into the harness that goes ahead of whatever you sent. So the first kind of main piece of privileged instruction that usually goes through is a system prompt. And a system prompt could be something as simple as, you are a helpful assistant. Please answer the user's question with honesty and work hard to achieve a favorable outcome for them. And then comes the user prompt, right? So you typed in, what's the capital of Korea? And the agent saw, you are a helpful assistant, blah, blah, blah. What's the capital of Korea, right? But that was tucked under whatever the model pre-posted. So like if you're sending this to ChatGPT, you said, what's the capital of Korea? And the harness prepended, you're a helpful assistant, blah, blah, blah to that, and then sent that upstream to the inference provider. And the inference provider ingested it into this sort of their pipeline for providing inference to you. And that pipeline almost certainly includes some pre-prompt provider side flavor, which means probably ahead of that, there's a bunch of instructions that are getting bolted onto the top that are things like, don't talk about goblins and don't make racial slurs and, all of this stuff. And then that whole blob is likely getting then fed first to input validation, where some other model is looking at it to see if you're trying to do hacking or bioweapon development, et cetera, right? So that's only, and we're just getting started. So the privileged instructions is a very important component. And whenever you're talking about a lot of times the big lab harnesses like ChatGPT or Claude Cowork or Claude Code, a lot of times the system prompt is not editable at all or even viewable, or it is editable, but like only a real power user is going and finding it and fiddling with it. So like with GPT 5.5, we started to realize after a while that it was really bad at front-end web development, not just because it had no taste, but because the harness literally was super opinionated about how front-end web development should look, which has two interesting knock-on effects. One, if you're just going to the ChatGPT app and you're asking it like to work on XYZ, it's getting system prompt saying, if you're doing front-end web development, you should use this style and you should do it this way, even if you're not even talking about that, right? Because it was part of the ChatGPT desktop application system prompt. Similarly, it's gotten much better, but like back around like January, February, the Claude Code system prompt was this monstrous absurdity. Like just thousands of tokens of possible things that might matter that don't apply to 85% of all the conversations going in. So the system prompt can literally dwarf your user prompt depending on how it's provisioned. And a lot of the open source harnesses that have grown in popularity considerably, like Pi, prominently expose the system prompt and prominently ship with a very lightweight and simple system prompt, leaving it up to you to develop an agent using that platform that includes the information you want to send. So what else is part of the harness that's kind of always there? So I think another big one is going to be environment context, bootstrap. So the information the harness is going to include with every prompt and ship to the AI about the environment it's in is going to vary pretty wildly across harnesses and systems. But the idea here is this is going to include, the operating system information, maybe some information about the code base you're working in, if this is a coding agent. It's going to include a lot of like information about the environment where the work is taking place. The next one is going to be tool definitions. So this is going to be things like read, write, bash, so like terminal scripting, maybe grep for searching, things like that. So these are built-in tools that the harness is letting the AI know it can use. And tool ergonomics are a huge part of how good or bad a harness feels. So like whether or not these tools are well described and easy for the AI to work with, or when these tools are complicated and buried in like layers of nested YAML or JSON, and the model has to respond in very specific ways to use them, can result in, a huge variance in how competent an AI feels. You might plug in like Gemma 4 26 billion into a harness that's like got really clean, simple tool definitions like Pi, where it just ships with read, write, bash, and grep and nothing else, and a really minimal system prompt. And the tool ergonomics are quite good. And you could plug in this very small, simple model, and it really feels like it can do a lot because it's not inundated with attention problems. Topic for another video. Then there are going to be more to this tool definition. So this is kind of like a subcategory here a little bit. But you'll also have the tools that get loaded. So more tools, which is going to be things like MCP tools, etc. And then potentially also you're going to have plugins or skills. So plugins and skills metadata. So let's talk about skills a little bit. So skills are just files typically of information, of context. But skills have what we call front matter, which is just YAML code in the top of like the markdown files that define the skill, that explain the purpose of the skill, hopefully. and help the agent decide when to use the skill, assuming the skill is automatically invocable, which most are, unless you have like explicitly set the false flag to make it not automatically invocable. So skills metadata. So this is going to be like, you have a skill called code review, right? And you should use this skill when reviewing code, might be the description. So that information is part of the harness's data that it sends to the model. Memory. A lot of harnesses include memory systems. Pretty much all the big ones do. So this is going to be why you can talk to Claude today about your hurt knee, and then tomorrow talk about planning a trip to do some hiking. And Claude's like, bro, you shouldn't do that one trail because of your knee. And you're like, we're not talking about my knee. That's memory. So Claude and ChatGPT both have proprietary memory systems. Claude's memory system was leaked in the Claude Code leak a while back, and it was quite interesting and very cool. And I'm sure they've developed it since then. Also, some open source harnesses have some really impressive memory systems. So Hermes agent, which I use quite a bit, has a very good, very robust memory system that makes use of markdown files and autonomously generated skills to be able to do, very intuitive work and kind of be ahead of the ball. So that's another component of what's being shipped in. And then here's a big one that you probably do know about to some extent, which is conversation history. So if the session ID for this particular chat isn't brand new, all prior user messages and agent responses are included in this conversation history. Now, conversation history isn't necessarily always every word of every back and forth, although it often is. A lot of these harnesses have background summarization and compaction that happens like in real time all the time outside of full compactions. Also, a lot of times, compactions will occur, and that's what a compaction really is when all of this subsequent data starts to get summarized. And that's why sometimes it makes the agents feel really dumb, is because all of the nuance that was in all of those previous messages got summarized and smashed, and now a lot of the details you talked about have been evaporated from the agent's context. And then finally, we get to the user message. This is what you typed into the prompt bar. We're going to highlight it in red because for a lot of people, they would see all of this that we've talked about so far as being AI and my message. And that's all there is. And the reality is, as we can see here, there is a lot more than just that. And below this, now we have a lot more going on, like autonomously gathered context, invoked skills, invoked tools, tool use history. There's so much more here. We're going to try to keep this simple and focus kind of on that first message, but we will need to glaze over those or touch on those just a little bit to be complete here. So let's talk though. Let's use this as an opportunity to talk about something that matters here a little bit, which is prompting. So whenever I ask an agent a question, and I don't have one pre-prepared here, so I don't know, something like do a review of my last commit, right? So I'm working in a code base and I send, this is my whole prompt. So this prompt kind of stands in opposition to a lot of what we've kind of heard previously around like prompt engineering. This was a really big hot topic in late 2025 of like, you need to really engineer a prompt. So this person might have alternatively said something like, you are a senior principal, super awesome expert code reviewer who's literally never made a mistake. Don't make any now. Wow, I cannot type today. Review my code. And a lot more stuff, right? So you get the picture. The idea is that we might choose to make our prompt very complicated and inject persona elements and other things to it to try to set the stage to get the outcome that we want. But now maybe as you read all of this, you can understand a little bit why that might not be needed every time, depending on how this is built and what happens here. Because if I send just this as the user message into a harness that is purpose-built for code review, it has skills for code review. It has a system prompt that says, you're an expert code reviewer that doesn't make mistakes. Don't make any now. It has specific tool definitions just for doing code review. So if I put this into something like CodeRabbit or something kind of a system like this that's designed to do code review, it's absurdly redundant for me to build a user message that is just going to get bolted onto the bottom that tries to contain orchestrator logic, like do this, don't do that. It tries to contain the system prompt by saying you are a XYZ. It tries to shape what the agent's going to do in a very redundant way. And I'm not saying it's harmful, right? So if thinking about this, like I typed in 50 tokens of information for my user message, and the agent got 10,000 because it got all the Claude Code stuff, and all of this stuff got sent to the AI. You've already got this huge session that you don't get to see as the user. But the point is that harness engineering becomes very interesting and very important when we start to understand what can be done here. I've always talked about how critical it is. I think it is that we engineer systems for the minimum viable user, right? You cannot predict who you're going to be working with. And yes, if I want to take a harness that is incredibly slim, something like Pi out of the box, that has a almost non-existent system prompt and minimal tool definitions and no loaded skills and no plugins and no MCP servers and that's it. It's just an intelligence getting dropped into a dark room. And then I provide a system prompt that's like, what broke here? That's the whole prompt. The agent now has to be like, okay, the hell is this guy talking about? Let's see. I've got some tools. I've got grep. Let's start with grep. Grep star, right? Like, what's even here? Okay, I've got some idea of what's here. What operating system am I on? Let's run bash and find that out, right? So like you can imagine 5 minutes later, the agent, if it's built with an intelligent model, has hopefully actually managed to take your absurdly vague prompt and turn it into an idea of what you're talking about based on context it has frantically gone and gathered. But if the harness is built for the user and the user's role, and the harness contains the guardrails and the rules and the pre-prompt and all that engineering was done for the user, then the user is free to ask natural questions like they would to a colleague at the desk next to them. And this is going to have no meaningful impact on the quality of the work. So when you go to a general purpose coding agent like Claude Code, and you ask it to work on things that are not coding agent work, and you find that by writing a more detailed, specific prompt with a lot of information about how you want it to work and what its persona is, you get meaningfully better results. Well, of course you do. The system prompt and the preloaded context is in opposition to the work you want to get done because you're working in a coding agent. So this is why prompting doesn't matter and prompting is super important. Can both be true statements depending on the system you're in. And we're very early, right? 2026, mid-2026, this is all moving very fast. And today, there are a lot of examples of general purpose agent harnesses and not a lot of examples of highly specialized, tested and tuned harnesses. And so what I would sort of summarize this all at this point, and hopefully you've gathered, is that the harness is the software that makes the AI useful to you. And this harness could be a general purpose piece of software like Claude Code that might be slanted towards software development and suitable for everyday work. And when using something like this, it follows the rule of universal fit tools. My first ever real job, I worked at a auto shop that worked on diesel trucks for the oil field in Texas. Had to be there at 4:45 in the morning to start work at 5. And there was an old guy that worked in the shop, and he would all the time lose his mind about any kind of adjustable spanner or any kind of a universal tool, because he was always saying that universal tools are all junk because they universally fit nothing. And I think that this is a decent analogy for the harness here, which is that a harness is kind of like a crescent wrench, right? It doesn't, if a general purpose harness like Claude Code or ChatGPT is not going to perfectly fit any socket. You're going to have to make some little adjustments to get it right. Or, this is the part that's really interesting, the upstream AI might have to do that. And you can work together so nobody has to work too hard, right? You put in the extra 3 sentences to steer the agent just a little. And then the upstream model is smart enough to be okay, what the hell is going on, but I sort of get it. And you meet in the middle. And that's why you can just jump. That's why tools like Claude Code and ChatGPT desktop and these different general purpose harnesses are so broadly useful, is because you don't need your whole specialist tool bag. You kind of got the one thing. But when we think about systems, kind of coming back to my day job, right? Advising folks on how to build and set up a security operations center to get the most out of the extremely valuable network-born context that ExtraHop can provide. And having these conversations around building agentic systems for specific use cases, I think the conversation moves a lot, right? We're hopefully not deploying general purpose, one-size-fits-all tooling in these scenarios. In these scenarios, we should be developing harnesses, developing software, deploying software that is built for the application. So when I go to deploy AI in my security operations center, I'm hopefully doing it in a harness that's purpose-built for security operations center work, that has robust orchestrator routing logic that makes it very good at doing security work. And it has a tool definition scape of all the tools the agent needs to do great work. It is maybe connected to MCP servers that expose subsequent environment-specific contextual tooling that allow it to, effectively and efficiently search local knowledge bases and understand organizational tribal knowledge quickly. And it has a system prompt that's tailored to the organization and the role and the specific environment, so that the user can sit down and not have to be some kind of, a prompting expert and have a clipboard filled with all of these saved prompts that they cherish because these prompts help them actually get good outcome. All of that is built into the harness, and then the user just asks the harness what they want to do, and that is handled upstream. I think that's mainly what I wanted to talk about today. Hopefully that was interesting. How long did we go? Just half an hour. That's not too bad. Let's do a couple minutes of bonus points here. See you later, or not. I wanted to talk just a little bit, as a PS here, about the agentic loop. So one thing that's very interesting is that the harness owns kind of this extra box down here, which would be the agentic loop. And, I just said it's a loop, and then I used a box. Let's use a circle. It's a loop. Why not? The agentic loop, and this is, a name for it, is going to be the process by which the agent does work. So there could be a lot of parts here, right? The agent now has stuff from up here, right? So it's got tool definitions, it's got MCPs, it's got skills. So it reads this last user message. Investigate this alert from my scene, right? Because we're talking about maybe security operations center work. We're getting out of the just specifically coding agent stuff. So all of this stuff here went into the machine. And this state machine, this whole kind of machine we're talking about, this is the agent, in my opinion. This is what agent means. The agent is the state machine that is the tools, the definitions, the user prompt, the system prompt, the upstream pre-prompt input validation, safety system. All of this combines to make the agent. And when the agent starts running, you get the agentic loop. And the agentic loop is the process by which work occurs. So based on what was included up here, the first beginning of the agentic loop is going to be a lot of like subsequent prompting where the AI will return information, the harness will do stuff with that information and send information back to the AI as a subsequent prompt. And these systems will prompt each other back and forth in a loop. And you're just kind of sitting there watching it say like Claude is pontificating, right? So like that's the agentic loop in action. And while that's happening, this is like, and maybe I'll talk through kind of an example. So it gets the information. It then is like, okay, first thing I need to do is read some files. So it's going to go use grep and read in some files. And it's going to say, based on the context in the user message, I need to go load a specific set of skills because the metadata strongly aligns with the intent of the user's message. So now we have some skills, and maybe we've got some skills over here like, SOC analyst, right? I'm just being generic. SIEM query language, right? So these skills contain additional ready-to-load context that the skill metadata help the agent choose to go load based on what it saw there. So these get pulled down into the agentic loop. Some tool like grep, for example, gets pulled down into the agentic loop and it's going to scan some files. And then memory, right? So it's like, okay, I need to go check memory now that I know what files I'm working with and the skills I've loaded. And of course, one other component, right, that the harness did here, investigate this alert from my SIEM. So more context can be included here. And so like in this scenario, the specific SIEM alert is maybe an attachment, right, to the user message, for example. Or the harness is dynamically loading it. Or a lot of times the SIEM alert is the user message. And investigate this alert from my SIEM was the system prompt, right? This was an autonomous agentic system that kicked off automatically. And a SIEM alert came in as the user message. And the system prompt was investigate this alert from my SIEM. So I'm just trying to like talk about other scenarios, kind of broaden this for you. Fresca break. All right, so, but I think you get the idea, right? So this loop runs in a circle as the agent does one thing at a time. Greps for files. That, with all of this, goes back to the AI. And it's like, okay, I've got the files, I've got all of this, let's scan memory. All of that goes back to the AI. And every time this is happening, the conversation history is incrementing, right? So like in this conversation history, I've got user, then agent, then tool, then agent, then tool, then agent, right? So like this goes on forever. And every time this happens, the conversation history is growing. And you can understand why a 500,000 or 275,000 or million token context limit can get devoured by an AI agent, because every time it does some reasoning, that's going into the context. Every time it calls a tool, that's going into the context. Every time it sends you message or you send it message and subsequently do more work, this is all going into the context. And context windows, are finite resources, but it makes more sense now how they can balloon. Clever harnesses can really do some work here around intelligently doing some of the cleanup. So whenever compaction or compression occurs, a lot of times what will happen is one of the first things to go is a lot of this tool call history, right? Like the agent used 50 tools Can we summarize that, get rid of all the failures, summarize the failures so it doesn't try them again, and produce like a summary of that? That's a low risk way to take 100,000 tokens out of the context window. But yeah, this loop is running, and there might be 30, 40, 50, 80 prompts in this session back to the AI as in one agentic kind of loop run before a final response message comes back to the user, as it, called extra hop to get network context, and it reached back to the seam to do like more queries to learn about other alerts, and ran this loop for a while. Okay, summary. Do we need one? I think we're good, right? I think we're good. So hopefully this was helpful. Hopefully you learned something. Maybe it was kind of interesting. I enjoyed getting to talk about it. Not that structured, but yeah, give me some feedback, right? So was this useful? Did you learn something? Do you feel better equipped to talk about these systems now? Do you now better understand the roles some of these things play? MCP servers for providing easy to understand tool surfaces for agents to pull in things and like have better ergonomics as they go to work with these tools. Skills as being, ready to go prompt augmentation so that the user doesn't need a 4-paragraph thesis as a prompt. Harnesses engineered for the job. Like there's a ton of value here in not just thinking you can use general purpose Claude for everything. You can. I can use a crescent wrench for every bolt to build a deck or something, but like that's going to be a shitty way to do it. So yeah, hopefully this is helpful. Hopefully this is interesting. Appreciate you hanging out, and let's do it again sometime.